This video is going to look at the cardiac system. So we're looking at the heart, your blood vessels. And write this down at the start of your notes because these are the things that are listed on your specification. You've got to know about blood vessels. You've got to know about the structure of the heart, what it looks like and being able to label it. You've got to know the cardiac cycle and how blood passes around the body and around the heart. And also three key terms: cardiac output, stroke volume, and heart rate. Now, on this diagram here, you can see the three main blood vessels we have. We've got arteries, which are larger, veins, slightly smaller, and capillaries, which we've already spoken a lot about in lessons. And what blood vessels do is they carry all that blood around our body. The arteries, and I always remember it with the A, arteries carry blood away. A for arteries, A for away. So arteries carry blood away from the heart. And it's always under a lot of pressure because you've got to think the heart's pumping a lot of pressure, carrying that blood away. And arteries are quite elastic. You can see on the diagram here, you've got a thick layer of muscle there. So it's quite elastic because it's got to maintain that high blood pressure going through it. Arteries have that ring of muscle, and that ring of muscle can contract, make the artery smaller, or it can relax and make the artery larger. That can change how blood flows around the body. So we've got vasoconstriction. And when something constricts, it gets smaller, so it reduces flow of blood. And on the opposite side, you've got vasodilation. When something dilates, it gets larger. The vasodilation is when the artery gets larger and allows more blood to flow. So during exercise, the arteries that are near your muscles going to vasodilate because you want to get more blood and more oxygen to your exercising muscles. The next one we're going to look at are those capillaries, those tiny thin-walled, remember they're one cell thick, thin-walled vessels that join up arteries and veins. And capillaries, their main job is gaseous exchange, allowing oxygen passing from the blood into tissues and allowing carbon dioxide to pass from your muscle into the blood. And also, it's not just oxygen, carbon dioxide that go across capillaries. You've got waste products, nutrients that are also going across them. And then blood flows from capillaries into veins, and veins take blood back to the heart. So veins, as you can see in the diagram here, they have much thinner walls because the blood pressure is a lot lower going through them. Remember, arteries have a lot of high blood pressure going through because they're being pumped from the heart. The veins is under a lot less pressure because it's just returning back to the heart. Veins also have valves. Again, V for vein, V for valve. So veins have valves, and that prevents any blood flowing backwards. And veins also have a much larger lumen. So this middle part here is a lot larger in a vein. That's one of their key characteristics. This is a really important table. It might be something you could try and print off and stick into your books. So arteries, if we remember, they carry blood away. A for arteries, A for away from the heart. Most of them carry bright red, oxygenated blood. They can stretch because they're under that high blood pressure. And that's where, if you ever feel your pulse, that's your artery you're taking a reading from. It's pumping up, pumping down, pumping up, pumping down. They have thick walls and also it's quite a small lumen, that middle part where the blood travels through, in comparison to its size. Capillaries now, these are those tiny networks. They link arteries and veins together. But they're very narrow. They're only one cell thick. And only one red blood cell can travel through them at a time. And they have very thin walls. Okay, they need those thin walls because things need to pass through and out of them. With veins carry blood, remember, back to the heart. And most of them carry dark red deoxygenated blood. They don't really stretch, they haven't got a pulse, and they've got a lot thinner walls than arteries. But their lumen, that middle part that the blood travels through, is larger in comparison to their size. And also the big thing that makes a vein is those valves. V for vein, V for valve. Okay, and it stops any blood flowing in the wrong direction. Now we're going to have a quick look at the structure of the heart. So if we look here, we're going to start with the blood coming back from the body at the vena cava. If I was a red blood cell, I'd be traveling in here. I'd come up into this top chamber called an atrium. I'd travel down into the ventricle, and then the heart will pump, and I'll get pumped all the way up the pulmonary artery. I'll get pumped up to the lungs. While I'm at the lungs, I get my oxygen. I come back into the heart once I've got my oxygen from the lungs. I'll come down, and I get pumped up the aorta to the rest of the body. Okay, so this is happening all the time. Always getting pumped up, pumped around the body. Now, we're going to have a quick look at the structure of the heart in more detail for that diagram you've just seen. So the heart is what pumps all our blood around the body. We know that. We've got two separate chambers. We've got chambers at the top called the atrium, and then our heart's also got lower chambers called ventricles. So the top two are atrium, and we've got our left and right ventricles at the bottom. And the atrium's job is to collect the blood from our veins. And then ventricles pump the blood. So once it goes into those bottom chambers, your heart contracts and it pumps blood out through the arteries. Now, the right side of the heart always receives deoxygenated blood from the veins and sends it to the lungs to be oxygenated, to get oxygen into those red blood cells to help it bind with hemoglobin. And oxygenated blood returns from the lungs into the left side of the heart. And then the left side of the heart pumps it all the way around your body to all your muscles and all your tissue that need oxygen. So remember, right side, deoxygenated blood, left side has oxygenated blood in it. Now, a sequence of events occurs when the heart beats, and these are key terms you have to know. You've got two phases when your heart's beating. And if you just put your hand on your you can find a pulse, or you can feel your heart on your chest, you can hear that boom, 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 boom. There's clearly two stages happening there. Boom, 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 boom. And the first one is called diastole. Now this is when your ventricles are relaxed and the heart is filling up with blood. And then after that, the ventricles contract, and that's the systole stage. So your ventricles contract and the blood is pumped out through your arteries to the rest of your body. You've got diastole and systole. And the cardiac cycle is completed when the heart fills with blood and then blood is pumped out of the heart. So it's got to fill up and then pump that blood out. Now, the left and right side of your heart go through those two stages, through diastole and systole at the exact same time. And then you've got the flow of blood through the heart. And that's controlled by pressure changes that cause valves to open and close. So you've got valves inside the heart that open up, but you've also got valves that close as well. And with diastole, the atrium, remember that's when the heart is filling up, the atria and the ventricles are relaxed, and the valves in the heart are open. So it allows blood to flow from the atrium down into the ventricles. You need those valves open. When deoxygenated blood comes into the heart from the vena cava, it enters the right atrium, that top chamber, and then goes through the atrioventricular valve into the ventricle. And it's called an atrioventricular valve because it links the atrium and the ventricles. So it goes from the atrium down to the ventricles. If you're trying to reimagine this and you're getting a bit stuck, go back on the video to where the picture of the heart was and look, follow the blood going from the atrium down into the ventricles. And you see that little valve in between them will be open so that the blood can travel down. During systole, the right atrium contracts and the contents go down into the right ventricle. And then soon after that, the right ventricle will contract and force all that blood out of the heart, along the pulmonary artery to the lungs. And at that point, that valve in between the atrium and the ventricles is closed. So no more blood can flow backwards into the atrium. And any deoxygenated blood goes through the pulmonary artery to the lungs, where we get all that gaseous exchange taking place. Now, in the lungs, so we've had our deoxygenated blood come back from our muscles, it's gone into our atrium, it's gone down to our ventricles, and it's been pumped up to our lungs. That's where we pick up oxygen. We get rid of any carbon dioxide. Once that process has happened, the blood returns to the left side of our heart, and it goes through the pulmonary vein. And then the oxygenated blood fills up the left atrium, okay, during that diastole stage. So our heart is filling up. And systole then begins again, and the atrium enters, the left atrium will fill up the left ventricle. So all the blood will drop down into the left ventricle and then be pumped up during systole. Okay, remember that valve in between the atrium and the ventricles will close up when systole happens, so that no blood can go back into the atrium. Then you've got cardiac output. Now these are key words you've got to know. So cardiac output is the amount of blood that gets pumped out of the heart every single minute. We usually measure that in litres per minute. And there's two things that affect our cardiac output. Our heart rate, which is the number of times your heart beats a minute, and also your stroke volume. So the amount of blood that is pumped out in every single beat. So you've got cardiac output, heart rate, and stroke volume. Three things that are really important terms that you need to know. If you increase your heart rate or your stroke volume increases, then that will also increase your cardiac output. And in class, we'll go through the formulas you need to know in order to work these out. Another thing that happens before exercise is your heart rate often increases, and this is called an anticipatory rise. So it might be even before you start doing any exercise, before a game, you feel your heart rate starting to increase. And stroke volume is increased by the heart contracting with more force. So more blood's getting pumped out of your heart with every beat, even before you've done any exercise whatsoever. This is usually the result of things like adrenaline being pumped around your body. And cardiac output and heart rate and stroke volume are related. And we've got this equation here, and we'll do a few of these sums in class. To work out your cardiac output, you need to do your heart rate times by your stroke volume. And we'll look at that in class.